My name is Michael Brown II. This is Calculus 1000 Challenge 2016. So our problem. Jane is 2 miles offshore in a boat and reaches the witch a coastal village 6 miles down a straight shoreline from the point nearest the boat. She can row 2 miles per hour and walk 5 miles per hour. Where should she land the boat to reach the village in the least amount of time? So looking at this information, we pull some various factors from the problem. First, her road distance being set up as a factor of a Pythagorean theorem equation is the square root of x squared plus 4, and this is at 2 miles an hour, while her walk distance would be 6 minus x, which is the distance where she's at now at 5 miles per hour. And so we know that time is equal to distance over the distance over rate. So by doing this, we set this up as our walk distance over the walk rate plus the road distance over the road weight, excuse me. Next, we take the derivative of our time, which will equal x over 2 times the square root of x squared plus 4 minus 1/5, and then we hit that with a common denominator, which gives us 5x minus 2 over square root of x squared plus 4 over 10 times the square root of x squared plus 4. We are then going to set the numerator equal to 0, which gives us 5x minus 2 times the square root of x squared plus 4 equals 0. Take 5x from both sides, and then square, which gives us 4x squared plus 16 equals 25x squared once you distribute the 4 on the left side. Now we want to bring the like terms together, so we have negative 25x squared plus 4x squared equals negative 16. Do the math, and that gives you negative 21x squared equals negative 16. X squared is equal to 16 over 21, and then take the square root, which gives us x equals 4 over the square root of 21, which gives us our stationary point from where she is located. We are then going to plug in the endpoints, which are 0 from her location and 6 miles, which is the distance to the village, based on the fact that we now have our stationary point, which gives us all of our critical points. So plugging 0 in will give us, as you can see, 2 over 2 plus 6 over 5, which equals 2.2. And that is her time walking from exactly where she left off. We do the same for our stationary point, and as you can see, once you plug it in, square root of 4 over square root of 21 squared plus 4 for 2 plus 6 minus 4 over square root of 21 over 5. And once you equate that, it equals 2.11 as our time. And then finally, we bring in our total distance as the critical point, 6, and that gives us square root of 6 squared plus 4 over 2 plus 6 minus 6 over 5, which gives us 6 plus 2 over 2 plus 0, which equals 4 for our time. This means that of all the times, the one with the shortest time was the stationary point, which gave us 2.11 as our time, which means that from the stationary point would be her fastest way to get to the village.